Today we're doing lesson 13.5, measures of center. The essential question, how can you choose appropriate measures of center and variability to describe a data set? Outliers, gaps, and clusters in a set of data can affect both the measures of center and variability. Some measures of center and variability may describe a particular set of data better than others. Okay, so it's a little bit confusing, that part. So we're going to get in. The most important thing to know for this lesson is the mean, which is the average. You add them up and then divide by the number of numbers. The median, which is the middle. The mode, which is the most frequently appearing. And then we're also going to talk about range today, which is the biggest number in your data set minus the smaller number. So for example, if someone had a group of students that were ages 5 to 3, the range of ages is 2 years. Okay, so 5 minus 3. All right, so here we go. Thomas is writing an article for the school newsletter about a paper airplane competition. In the distance category, Kara's airplanes flew 17 feet, 16 feet, 18 feet, 15 feet, and 2 feet. Should Thomas use the mean, median, or mode to best describe Kara's results? Explain your reasoning. The first question we need to ask, do we need to put these numbers in order from least to greatest to find any of those things? Riley? Yes, we do. We need it for the median, right? To find the middle. So, yes. To determine the median, copy this down. To determine the median, the numbers need to be in order. Yes, to determine the median, the numbers need to be in order. Jenna, will you show Riley how to give herself a point on the iPad back there at the cabinet? So Riley, go with Jenna and she'll show you. Okay, so first they want us to find the mean. We don't need to put them in order for this part. We just need to write them down and add them up. So 17, 16, 18, 15, and 2. And how many numbers are there? 5. When you add those all up, you get 68 over 5. Type that into your calculator and see what 68 divided by 5 is. 13.6. 13.6. So our mean for this data set is 13.6. Now we have to put the data in order from least to greatest. 2 is the least. Then we have 15, 16, 17, and 18. So what would the median be? 16. Because 16 has 2 numbers before it and 2 numbers after it. So the median is 16. The data set has no repeated values, so there is no mode. Okay, and now it says the mean is blank less than 4 of the 5 values. So the 13.6, do you see that in our values 2, 15, 16, 17, and 18? The mean would be right here, right? and that's lower than 4 out of the 5 values. So the mean would not be a good description of the distance that her airplane flew. So the mean is less than 4 of the 5 values, so it is not a good description of the center of the data. The median of 16 is closer, you getting this down, Avery? To most of the values, so it's the best way to describe Kara's results. So Thomas should use the median to describe Kara's results. In this case, 2 is probably an outlier, or like a fluke kind of thing. So she was flying the airplane, they were going great, and then she was like, oh, and she tripped, and it only went 2 feet. So that could have thrown off her whole thing and made her look like she wasn't very good at making airplanes. But when in reality, she was better than that. Okay.
A professional.
Explain why the 2 modes in this number, or in this data set, may be a better description than the mean or median of the data set. Okay, so let's find the mean and median. So we've got 8 values there. There's 4 2s and 4 7s. So if we add those up, 7 times 2 is 14, 14, 14, and 14. So what's 14 times 4?
56.
56 divided by 14 times 4. Yeah, 56. Oh, it's 9. I was multiplying. That's why I was confused. I'm like, it's not. It should be 9 times 4. Sorry. 36 divided by 8 values. So sorry, guys. I was multiplying, but I should have added. 2 plus 7 is 9. 2 plus 7 is 9. So 36 divided by 8 equals 4.5, right? Okay, so the average is 4.5. Then if we do the median, we've got a rainbow. That goes with that, that goes with that, that goes with that. The average of 2 and 7 again is 4.5. So in this set of data, the median and the mean are both 4.5. So the mode though, because both of these have or it has 2 modes. It has 2 and 7. The best way to describe this data would be with the modes 2 and 7. So here we go. Copy this down. The mean and median are both 4.5, but that value doesn't show there are 2 clusters of values with a gap in between. The modes 2 and 7 represent every value in the set. You better start copying. There's a lot. online. He compares prices of the book at several different sites. The table shows his results. Make a box plot of the data, then use the plot to find the range and interquartile range. Which measure better describes the data? So you guys know what the range is, the biggest minus the smallest. Do you remember yesterday when we were doing box plots, how we found the lower quartile and the upper quartile, the center of the first half and the center of the second half? The interquartile range is that the center of the, or the upper quartile minus the lower quartile.
I forgot to change it back to button, so we'll show the answer on this one.
Oh yes.
Come on.
I'll put it back up there in a little bit. Okay, so here we go. They want us to make a box plot. So the first thing that we have to do, like it says, is write the data in order from least to greatest. So the smallest or the cheapest book price is $5. And then we have a $15 and a $16. Two of them are $17. Then an $18 and a $35. So since there are 7 values here, there would be 3 numbers before the center or median and 3 numbers after. So what's the median? 17. The lower quartile, remember, is the center of the first half. So what's the center of the first half? 15. The upper quartile is the center of the second half, which would be 18. Good, guys. Okay. I am Facebook friends with this author. So I started following him on Facebook because I really liked his books. And then I entered a contest and I won a t-shirt in the contest. And then, right? And he ended up sending me like an actual friend request from his personal account. And he's a super nice guy. He's a young guy and he's got a wife and a baby and he's amazing and just a great author, and he really interacts with his fans, which is really cool because a lot of authors don't do that, you know. They're like, those fans are beneath me. But one time, so his books are usually, they're novels, fiction books, and they're usually about 20 bucks a piece. Well, once Amazon made a mistake and had one of his books listed for $2,000, and somebody, one of his other fans, shared it with him and was like, I can't afford your book this week or whatever. And just, but if he was taking an average of like his book prices, then that could really skew his numbers, right? Because that maximum value is $2,000 when none of his books cost that much. Really, it was because of a mistake. So 2,000 would be an outlier, like a mistake or a fluke or something that isn't right.
How do you accidentally do 2,000 instead of 20?
They put 2 extra zeros.
It makes sense if they did like 200.
Right, well, not exactly, because on some websites you just type in 20 and then it automatically fills in the rest for you. But some you have to, this would be 20 cents, so you have to keep going and in order to get $20. So I'm sure something like that happened.
Imagine if you put it for 27.
Yeah, I know, he would have been, his books would be flying off the shelves. It's like,
A show about a store and someone put 25 cents on everything.
all right, let's make our box plot. We have all the information we need. We've got the minimum, the maximum, the median, the lower quartile, and the upper quartile. So the minimum was 5. So you go to the 5 and then you make a dot above it. Then the maximum was 35. So we go find 35 and we make a dot above it. And then the median was 17, so I'm gonna go above 17. The lower quartile was 15, and the upper quartile was 18. So that one's gonna be between 19 and 17. For the first and last, we're gonna make these horizontal lines. For the center 3 are going to be vertical lines that we connect at the top. So now, in a box plot, most of our box plots don't look like that. They're more spread out because the data varies more. But in this case, everything's kind of bunched up. So we need to find the range, which is going to be 35, the highest price, minus 5, the lowest price. That would be a range of $30 for the books. But most of these values are in the teens, aren't they? So we have 15, 17, 18, 16, 17. Most of them are in the teens. So the upper quartile minus the lower quartile, 18 minus 15 would be a range of 3. So since they are, most of the data is within that, the box, we're gonna put down, that, so it says 5 of the 7 prices, so write this down, 5 of the 7 prices are within the interquartile range. And we're going to abbreviate that going forward as IQ, interquartile range. So the IQ range better describes the data. IQ range. That's not like an IQ test, which stands for intelligence quotient. The interquartile better describes the data because the range makes it appear like the data is values vary more than they actually do. Okay. At the bottom, it says, how can you tell from the box plot how varied the data are? The shape of the box tells how varied the data are. A short box means the data is less varied. A long box means the data is more varied. So that's in general. Copy this down. I think this is the last of the longer answers that we have to copy down. I don't really like the way that it words it. The shape of the box tells how varied the data are, because I think of data as like a singular thing, and think of it as is, but because there's multiple points, they set it as are. Yes.
So is it like that because it was on the right answer?
Yeah. Yeah.
Shouldn't it be like data's or because like that means that one of these
Yeah.
that is singular.
Yeah. Because there's multiple points of data, they look at it as plural. Okay, but then on the last two, I changed it to is because I think it sounds better. Okay. All right. If you didn't quite finish, I'll put it up at the end. Okay. The distances in miles students travel to get to school are 7, 1, 6, 8, 9, and 8. Decide which measure of center best describes the data and explain your reasoning. So we have, what is my least? 1, and then, okay,
7,
okay,
2, 8,
okay. All right. So we have 1 with 9, 6 with 8. What would be our median? 7.5. Okay, 7.5. So the median is 7.5. Let's add these up. 1 plus 6 is 7. 7 and 7 is 14. 8 plus 8 is 16. So 14 and 16 is 30. Plus 9 more is 39. And then there's 1, 2, 3, 4, 5, 6. 39 divided by 6. 6.5. So the mean is 6.5, and then the mode would be what? 8. So we need to look at which of those three best describes the data set. So we have a 7.5, which is the median. We have a 6.5, which is the mean. And then we have an 8, which is the mode. Which one of these best would be the center of the data? Ian? The median. Okay, for this one, right? Because this is the mean, would be here. This would be the median. This would be the mode. So the most center of them. So the mean is less than 4 of the 6 data points. So the mean over here, there's 1, 2, 3, 4. Less than that. And the mode only describes 2 of the data points. So the median best describes the data. The numbers of different brands of orange juice carried in several stores are: make a box plot of the data and find the range and interquartile range. Decide which measure of center best describes the data set. Okay, so first let's put them in order. We have 3 1s, 1, 1, 1. We have 3 2s, 2, 2, 2. We have a 3. We have a 5. And we have a 12. So there's 2, 4, 6, 8, 9. Okay, so that's all of them. So, the range, well, first they want us to make a box plot. So we need the median. So we've got, we can go ahead and plot the 1 for the minimum and the 12 for the maximum, Avery. And then the median, 1 would go with 12, 1 would go with 5, 1 would go with 3, 2 would go with 2. So the median would be what? 2. So we're going to plot a point at 2. Then we've got to find the lower quartile, the middle of the first half. So here is the median right here. So that goes with that. What's between 1 and 1? 1. Just between 1 and 1. And then what's between 3 and 5? 4. So this upper quartile would be 4, the lower quartile would be 1. Uh-oh, we've already got a point at 1. So that means, you know how box plots start normally with a line that goes here and then a line here and then the box in the middle? Okay, we're not going to have that beginning line on this one because our box starts at the same as our minimum value. So here we go. So we've got to put a point at 4. And the box is made up from 1, the lower quartile, 2, the median, and 4, the upper quartile. So we make a box like that, and then we connect these two. So your box plot should look like that. So just copy this down. What would the range of this data be?